Hi guys, today we are talking about matter. Matter is the basics of everything we're going to talk about for the rest of the semester in chemistry. So what is matter?
Well, I think matter's like everything, right?
It is. I mean, it is like literally everything except for energy. Matter is anything that has mass or takes up space. Space we're talking about in this case is volume.
What about air?
Air has, it does have mass, even though it doesn't seem like it, right? It doesn't seem like it's heavy, but it does have mass and it does take up space. So if you blow up a balloon, you'll see that the air is in fact taking up space. Now things that don't have mass or take up space would be energy, which would be electricity or light. So those things are not matter. So let's talk about some examples, all right? We have right here some petri dishes, and these are going to represent the two different types of matter. The two types of matter are pure substances and mixtures. What do you think about when you think of a pure substance?
Whenever I think of a pure substance, I think of something that's the same all the way through.
That's a really good way of looking at it. It's the same thing throughout, okay? So we have right here a petri dish it's only got screws in it, nothing but screws. So those are the same objects all the way through the whole substance.
A few of these are loose.
They are, yeah. But I mean, they're the same thing. We only have screws. We don't have screws and nuts, right? Yeah. Over here, we have just nuts and no screws.
Ah, okay. So because these are all nuts and these are all screws, these are pure.
Yeah, that's a pure substance, and this is a different pure substance.
Okay.
We can put them right here and see. Right? They're the same thing all the way throughout. So we can pretend like the screws and the nuts represent atoms. Two different atoms, but they're the same kind of atom all the way through. So what do we call that whenever we have a substance that's the same type of atom throughout?
I guess a pure substance.
It is a pure substance, but it also has a name, right? That name is element. The elements on the periodic table are all the same, atom all the way throughout. They're different, like they're different atoms, so we have different elements, but they're the same thing, right?
Can you ever have two elements in a pure substance?
Yeah, you can. We call that a compound. So right here, I actually have a screw and a nut. They're attached to each other, but you can see that they're the same thing, right?
Oh. So they're two different things, but they're combined.
Mm-hmm. But you can see how it all still looks the same throughout.
It does. All of the screws have one nut on them.
Mm-hmm. So that is a compound. Okay, so over here we have pure substances, right? We have two elements, two different kinds of elements. And then here we have two elements that are stuck together, and we call that a compound. Now, if we took this compound and this element and we mixed them together, we would get this, which is a mixture.
Oh, that makes sense.
It's when you have two different things together, but they're not fastened to each other. They're not chemically bound, right?
So this is chemically bound,
Mm-hmm.
and this is just elements, but when you mix them, they're a mixture.
You get a mixture. I can't separate these two without changing the identity of that substance. These things I can separate.
Gotcha.
And what do you think we have right here?
Well, I think the screws are a pure substance,
Mm-hmm.
or elements, and I think these washers are just elements, but they're all together.
Are they attached to each other?
It doesn't look like they're attached to each other, so I think they're just mixed together.
So what would we call that?
A mixture.
That's right.
All right.
So here we have pure substances, and here we have mixtures. Right? Now, let's talk about some real life examples. What do we have right here?
It looks like water.
It is water.
Okay.
And what can you tell me about the water?
Well, the water looks like it's the same all the way through, just like those nuts and bolts over there.
That's right. Yeah, we can't really see any differences here just by looking at it, right?
Mm-hmm.
Now, what about the formula of water itself? What do you know about water, like what it's made of?
Water is 2 parts hydrogen, 1 part oxygen.
And are they bound together?
I think so.
Yes, they are. They are bound together. So we call that a compound. So even though water looks the same throughout, it's actually made of two elements bound together. in a compound.
Mm-hmm.
We can't separate those two without changing the identity of water. It wouldn't be water anymore if we took them apart. So this is a pure substance. It is a compound. Now, what would happen if I get the sand and I dump it in there? Oh, there you go. You got the compound right there.
Mm-hmm. It's a compound. It's all the same.
Mm-hmm. So those screws and the nuts can represent the molecules of water.
It's just like water, but if we were to add sand, I think that'd be a mixture.
I think so too. Let's check it out. There you go. We can stir it up.
So I have a question.
Mm-hmm.
How would we know that this is a mixture and not just making them all bound together?
So the only way we'd be able to tell that is if we tried to separate it. So if I ran this water and the sand, if I dumped it all through a filter, the sand would get taken out, right?
Mm-hmm.
Some of the water might too, just sticks to the sand, but they're not chemically bound together like that. I can purify this water again, just like your drinking water, right? It gets purified whenever it goes through the filter, so you can drink just the water and not get all that junk in there.
So if you ran it through a filter, the sand would be gone and you'd be left with the water.
You'd be left with just the water. That's right.
Right, okay.
And it looks different. So this is a mixture where we can tell the two different parts. We can see them just by looking at it. It doesn't look the same all the way throughout. We call that a heterogeneous mixture.
Oh, because hetero means different, right?
That's right. There are two different types of mixtures. The first one is heterogeneous, where things look different. You can see the individual parts without having to chemically separate anything.
Like where the sand is at the bottom and the water's at the top?
Yeah, that's right. And we got some sand floating on the top too. It's kind of good. All right, now what about salt and water?
Well, I don't think all the salt would go at the bottom. Doesn't salt dissolve in water?
It does.
Huh.
Let's try it out.
Most of it looks like it's just disappearing.
I mean, what does it mean if all of it's dissolved in here and it all looks the same thing?
So, are the salt and the water bound together, do you think?
I think so.
I don't think so. I think if I evaporated this water off, I'd be left with just salt. Kind of like, that's how they filter seawater, right?
So even though it looks like it's the same thing, it's actually different things in between the water.
Right. We haven't made anything brand new chemically by putting the salt in the water. It's still just salt and water, even though it doesn't look like it.
Oh, okay.
So mixtures that look the same throughout, we call those homogeneous mixtures. Because homo means what?
The same.
It means the same, that's right. So we have two different types of mixtures. One of them looks different. The different parts are clearly visible. That's called a heterogeneous mixture. And then one that looks the same throughout, even though there are different parts, is called a homogeneous mixture. So we have mixtures here, and we have pure substances. Pure water is an example of a pure substance. And we have mixtures. Sand, right here, is an example of a mixture. And these are also examples of mixtures.
Oh, because they're all different little rocks in there.
That's right.
Okay.
What kind of a mixture do you think this is?
Well, I'm not sure. It looks like you have all different types of rocks, and they look like they're pretty well the same throughout. I would say it's homogeneous.
I think it could go either way. I mean, you can kind of see that there's different types of rocks in there, but it is evenly distributed.
Well, I think if I kept shaking it, all the big rocks would probably go to the bottom. Yeah, I guess it could go either way.
That would make it a heterogeneous mixture if they did, separate it out. What about the air that we're breathing?
Well, I would think that if the air that we were breathing wasn't homogeneous, then we might hit some pockets where there is no air and we'd die.
Ooh, that'd be really bad, right?
Yeah.
So air is in fact a mixture of nitrogen, carbon dioxide, oxygen gas, all that. So it's a mixture of gases, but it looks the same all the way through. So air is also a homogeneous mixture.
All right.
I think we've covered everything. If you have any issues, any questions, be sure to ask your teacher and make sure that you write down a good summary of your